Alrighty, welcome everybody. This is the Showcase webinar series. My name is Jonah Hobson. I'm the marketing manager here at ITI, and today's presentation is entitled A Journey Below the Hook, and it's all about below the hook lifting devices. We're back after summer break. I don't know if everybody got summer break, but we took one with the webinar series, but we're back and we're very, very excited to have Paul Sweeney as our presenter today. Paul is the owner and founder of Riverside Engineering. And as you can see on the screen there, he's a member, volunteers his time to ASME, sits on a number of committees, chairman of the B30.1 subcommittee, and we're very stoked to have him, so thank you to Paul. I'm going to run through just a brief introduction to ITI, who we are, to new folks who are on the line, and then we'll get things over to Paul. So let's dive right in. So if I could summarize ITI in one sentence, it'd be the sentence you see on the screen there. We exist to serve and learn every day. We have clients that we work with, some of which you can see on the screen. We're very proud to have a part, even if it's a small part, in their success as an organization and a company, and to help their people with continuing education and development. We placed the image on top of a world view there because our guys have literally trained everywhere, every continent, I believe, except for Antarctica, over 60 countries, every state in the U.S., every province in Canada. So just very proud, and again, it all boils down to that sentence at the top. We exist to serve and learn every day. We actually got a sponsor for our webinar series this year. We've been doing it since 2012. But Lifting Gear Hire, we're proud to have them on board. They support what we're trying to do with the webinar series and just focus on a lifting, rigging, lift planning topic every month. Free resource for everybody in the industry. We record these, we put them in our archives so you can refer back to them at any time. But yeah, they reached out to us about it, and we're thankful to have them on board, thankful for their support. It's a great company. If you do get the time and you're in need of a lifting device, please visit their website, www.lgh-usa.com. Then a little bit more into ITI, who we are. Obviously, training is the core of what we do here. We're very proud of our e-learning offerings, which roll into training. We have a reference center, the ITI bookstore as well. So if you want to do some self-learning, some great resources there. Check out the bookstore. We have run a consulting arm of our company. We call it field services, but doing audits and like lift plan reviews and things like that, accident investigations, which we hope you guys don't have any out there, but we can do that as well. And then webinars like the one we're on today. So I mentioned at the top we have Paul Sweeney joining us today. Thank you again, Paul. He was formerly the manager of lifting and handling equipment with General Dynamics Electric Boat. He just retired from there this year in 2016. He has been an instructor at the University of New Haven for, I believe he told me, 17 years at the top of this call. Still doing that. And again, a number of the ASME committees that he's a member of. And for those of you who don't know what ASME is, it's the American Society of Mechanical Engineers, and what they do, nonprofit, volunteer for the most part organization. They help set the standards when it comes to anything engineering-wise. You might see ASME, whatever the number of the committee is, on a number of the products you get, that it's approved by that. On a sticker when you buy something new, and that's what they're doing. So it's pretty behind the scenes, but very, very important work. Finally, we want to make this as interactive as possible. We leave time at the end for a question and answer session. So I'll kind of fade into the background on this webinar after this slide. But if you do have questions, I'll be fielding those digitally behind the scenes, and what I'll do is feed them over the air to Paul. at the end of the session if we have enough time. So yeah, if you have questions about anything, something he says or an image you see, shoot it over to me, and hopefully we'll have time to address it at the end. And then with that, I actually want to just launch a very brief poll. Pretty easy here, but it's basically, have you ever participated, or have you participated in whether that's planning, execution, or oversight in a lift that utilized a below-the-hook lifting device in the past 12 months? So I'm going to launch that very briefly. Just a yes or no. Very simple. It's just to kind of get a baseline and to see where we're at. And it's okay. There's no right answer, obviously, but yeah, it's just interesting. So I appreciate you guys participating in that. I'll leave it open for about 5 more seconds here. And it looks like we got some results coming in. Most of you have voted, so thank you. It looks like about 3/4 of you guys have. And again, it's whether that's executing a lift, planning, or just general oversight. So that's interesting. Thank you for voting. I'm going to close that now. And with that, I am going to turn things over to Paul. So I'm passing him the screen right here. Thank you, guys. And Paul, go ahead and take it away when you're ready.
Thank you very much, Jonah, and welcome everybody to below-the-hook lifting devices. Let's start off with what a below-the-hook lifting device is. The ASME B30.20 definition is a below-the-hook lifting device is a device used for attaching a load to a hoist. It may contain components such as slings, hooks, and rigging hardware addressed by other ASME volumes or standards. Below-the-hook lifting devices are also called lifters and lifting devices. What is not a below-the-hook lifting device? Well, shackles, links, rim, swivels, turnbuckles, eye bolts, hoist rings, rigging blocks, etc. Although these devices are certainly used to connect loads to hoists, this equipment is not considered to be below-the-hook lifters, but rather it's detachable rigging hardware. And B30.26 covers detachable rigging hardware, and slings are addressed by ASME B30.9. Let's go through a whole bunch of examples of below-the-hook lifting devices. Walker Magnetics, a great company up in Massachusetts. Ken Jankowski sent me these pictures. So these are magnetic lifting devices. They're real gizmos. They're very fancy things, several articulating arms. This one in particular picks up that square tubing and also channel iron. Here's another magnet system that picks up piping. This still is a below-the-hook lifter, even though it's on a forklift. There's a pad in the center that could certainly be hung from a crane. This picks up plate. Another magnetic device picking up a very thick slab. Here's a coil lifter. This device picks up several pieces of railroad track at a time. Another plate lifter. Here's another magnet. This would be for plate lifting also. More plate lifting. Of course, someone's at the door right now. Here's some magnetic lifters that pick up big chunks of metal. This picks up pipe. Here we have a very strange magnet that picks up some sort of, I guess, extruded pieces of rounded piping. The purpose of all this is to show you just how many different below-the-hook lifting devices there are. This is a permanent magnet lifting device, picks up round, stock, and plate. This magnet picks up rings. I don't know exactly what those are for. It might be some sort of slewing bearing arrangement. Another magnetic thing like a positioning table almost in upside down. Here's a below the hook lifting device that, again, I think this is the opposite side of that magnet. More magnets. Here are a combination of spreader bars and slings suspended from a crane picking up some very large thing. I think Randy Stemp from Lamson sent me these. This is more of a circus act than a lift, it seems, but it employs 1, 2, 3, 4 lifting bars, each arranged differently to make sure the center of gravity remains under the hook. This is another wild arrangement. These lifts that Lamson does are hundreds of tons and quite well engineered. Gary Bonds from Wood Power Grip out in Montana sent me this. Wood Power Grip makes vacuum lifting devices, another major category of below the hook lifting devices. Here's one installing glass. More glass from Wood Power Grip. You can see the vacuum lifter suction cups here. This is some sort of sheet material picked up again by vacuum lifter. More of the same. I'm not sure what this material is, but again, vacuum lifters. Building facade windows picked up by a Wood Power Grip vacuum lifting assembly. More glass. Still more glass. This looks like maybe it is countertop material, granite or something. This is definitely a granite countertop being lifted by these devices. Automobile and glass industry uses an enormous amount of vacuum below the hook lifting devices. Now this looks like building facade material, again with a vacuum lifter. More of this. These are fairly complicated and intricate machines. This is certainly designed just for this particular application. More granite countertop material. Gary said that they sell an enormous amount of these to granite manufacturers. Now Doug Berensky, who owns Hunter Lift, sent these. He's in Pennsylvania and makes enormous devices that primarily used in the steel industry. This would be some sort of grab. A fairly standard lifting beam, but you'll see that there are sheaves on the right and left side. Those would hook into hoists. This would be a grab used for molten material. I think this is lifting salt. But these are all examples of below the hook lifting devices. I think we saw a picture of this one earlier. Again, it's another coil grab or slab grab. It's called a tong. Articulated arms. It works just like an ice tong. More of the same. These on the extreme edges would grab the lip of something. Another example of a tong from Hunter Lift. Some more vacuum lifting devices. This is almost a flying forklift, I would call it. Here's a spreader bar with 2 anchor hooks with a very large place to hook it on in the center. Now this device is again another tong. Very specialized, it seems. Those little nubs fit inside these pipes on whatever they're picking up. Willie Radu out at Mozilla sent me these pictures. This is probably one of my favorite below-the-hook lifting devices. See, it incorporates web slings and spreading devices. This is a coil grab pressure one. It doesn't indent, but rather the padding on the sides holds the load. Some sort of frame, not exactly sure what. This, again, another example of some type of grab. This would be articulated. You pick it up, and the tongue action grabs whatever you're hoisting. A coil grab. So here's a frame. Another frame, this would be some sort of barrel lifter where you could actually turn the barrel and dump it. Some type of coil grab. Can I excuse myself for 1 second? A giant truck has just pulled up out front with a delivery, and I will be right back.
All right, sorry about that, guys. Think of this as a brief intermission. I know the beginning portion of the presentation, we have a few more below-the-hook lifting devices to look through, but as we get going towards the middle and the end of the presentation, there'll be some good explanations, some use cases, kind of case study type stories, and yeah, we'll get there eventually, so hang with us. Sorry about this.
Thanks, Jonah. I'm back. Delivery, of course, was supposed to be after 3. But
no problem. That's how it goes. Anything can happen on the webinar series.
Yeah, arranged it specifically so it would not interfere. Anyway, thank you.
Yeah, no problem.
Please excuse me. Again, some articulating tongue device. If it's under something, grabs it and holds it. I have no idea what this would be used for. But again, it's a lifting frame with 4 square things that probably fit over handles in the device being picked up. The point of all this is that there are a million different types of below-the-hook lifting devices for a million different applications. Most are different. This is some sort of pipe grabber that the long arm will position this, the short arm engages or disengages it. Again, a giant lifting frame to pick up something that has those trunnion pieces on them. This would be some sort of molten material thing or something that has to be dumped. Dave Dewar out in Texas sent me some of these. This is the work he does. He designs these fancy lifts. Here's a 2-crane pick using a lift beam on top to share the load between the 2 cranes, and then a lift beam on the bottom used in order to hook the load to the beam. Here's a spreader bar used to upright something. Dave does a lot of work in the petroleum industry and refineries. Again, series of spreader bar arrangements used to pick up very heavy pieces of machinery. Let's talk about some of the specifics of below-the-hook lifting devices. Marking requirements. Marking requirements for the below-the-hook lifting devices are found in ASME B30.20. B30.20 is the definitive document that governs below-the-hook lifting devices. And the marking must include the manufacturer's name and address, the serial number, the lifter weight, if it's over 100 pounds, the electrical requirements, if applicable, rated load, and the ASME BTH-1 design category and service class. We'll talk about those in a while. All lifters have to have product safety labels, where the size and shape of the lifter allows, that provide danger warning or caution notices to the operators and others against all of these things. You can't exceed the rated load. You can't operate damaged or incomplete or malfunctioning lifters. You can't lift people with them. You can't lift suspended loads over people. You can't leave suspended loads unattended. You don't remove or obscure the warning labels. You do not operate the lifter without having read and understanding the manual. You have to stay clear of the suspended load. Lifting loads higher than necessary is prohibited, and you cannot alter the lifter. Now, if the lifter has been repaired or altered, it shall be displayed with the following information: the name of and address of the repairer or the alterer, the repairer or alterer's unit identification, the lifter weight, if it's been changed, the electrical requirements if it's been changed, the rated load if it's been changed, and the design category and service class if they were also altered by the alteration. Now, one thing that's not on the slides is most product safety labels don't contain all that information. It's very awkward and not really, in my opinion, the right place to put all that information. There's an option in B30.20 to install a warning label that says you have to read the manufacturer's or lifter's instruction manual and make yourself aware of the product safety requirements. Now, the controls have to be marked. Each operating control should be clearly marked to describe the resulting motion or function of the lifter. If valves are incorporated in the lifter, such as shut-off valves on vacuum lifters, the valves shall be marked to show the operation, meaning on or off. Personal competence and training is very important. Outside of inspection, it is the most important. Below-the-hook lifting devices shall be operated only by trained personnel, and the operator of the device shall be trained or instructed in the use of the lifter. The training should include the following: how you apply it to the load and make adjustments, any special operations or precautions. You have to read the manual to learn what the operating procedures are. You have to know what the condition of the load required for operation of the lifter is, such as balance, surface cleanliness, flatness, bending, and load thickness. This is incredibly important with vacuum lifters and with magnets. You have to know how to store the below-the-hook lifting device to protect it from damage. You've got to know you're not supposed to exceed the rated load of the device or the hoist by the combined weights of the load, the lifting device, and the rigging. Everything below that crane hook counts. You have to know how to charge the batteries if it has batteries, and what the meters, alarms, bells, and whistles mean. The operator of a below-the-hook lifting device shall demonstrate the ability to operate the lifter as instructed before assuming responsibility for using the lifter. The operator of a lifter shall be familiar with standard hand signals when applicable. Now, just like your car, you have to maintain below-the-hook lifting devices. A maintenance program shall be established based upon the recommendations of the below-the-hook lifting device manufacturer. The maintenance program may also include the recommendations of a qualified person based on a review of the lifter's application, environment, operations, etc. As I mentioned earlier, I think inspecting the below-the-hook lifting device is probably the most important thing you can do. All inspections of below-the-hook lifting devices shall be done by a designated person. Any deficiencies identified shall be examined, and a determination made by a qualified person whether those deficiencies constitute a hazard. All new or altered below-the-hook lifters shall be inspected prior to initial use. Now, there's three types of inspections that have to be performed. You need the every lift inspection, you need a frequent inspection, and a periodic inspection. Let's talk about those. The every lift inspection. The operator shall inspect the lifter before each lift for indications of damage and shall observe the lifter during operation for any damage or anomalies that might occur during the lift. Written records are not required for every lift inspection. The operator will also inspect the surface of the load for debris or the surfaces of the magnet and the load for foreign matter and the seal of vacuum pad for debris. The first part, the surface of the load for debris. You don't want anything to fall off the lifting device while you're fall off the load while you're picking it up with the lifting device. Now, your operator will also check for the condition and operation of the controls and the condition and operation of pumps, meters, indicators, etc. as applicable. That would apply to batteries, indicators, electrical indicators on magnets, and vacuum lifting devices. The frequent inspection. Now, the operator or other designated person shall inspect the lifter for damage at intervals based upon the severity of the lifter use, and shall observe the lifter during operation for any damage or anomaly that might appear between inspections. Written records are not required for frequent inspections. Now, if it's normal, you perform the frequent inspection monthly. If the service is heavy, you inspect weekly to monthly, and if it's severe service, such as in a steel mill, you inspect daily to weekly. For all lifters, the frequent inspection shall look at structural members for deformation, cracks, broken welds, excessive wear, loose or missing guards, fasteners, covers, stops, nameplates. All functioning operating mechanisms need to work properly. They'll also check for missing or illegible operating control markings and items specific to the type of lifter, like vacuum systems or magnet surfaces. The periodic inspection. A complete inspection of the lifter shall be accomplished at intervals shown below. The periodic inspection includes all the items checked during the frequent inspections. The written and dated records are required for periodic inspections. A mark on the lifter indicating that the inspection has been performed in accordance with a standing instruction satisfies this requirement. Now, yearly, that's inspected for normal service. If you have heavy service, you inspect twice a year, and if it's severe service, you inspect every 3 months. For all lifters, the periodic inspection shall look at all items looked at on the frequent inspection, loose bolts or fasteners, cracked or worn gears, pulleys, shivs, sprockets, bearings, chains, and belts. You check for excessive wear of friction pads, linkages, tongue points, and other mechanical parts, excessive wear at hoist hooking port, and the load supporting clevises or pins. You check for missing or illegible product safety labels, and you look for external evidence of damage to the support structure, motors, controls, and other components. All electrical components, including electric resistance and ground checks, shall be checked for magnet coils. Testing of below-the-hook lifting devices. All below-the-hook lifting devices shall be tested before they are placed into service. Testing of below-the-hook lifters takes 2 forms: operational tests and load tests. Data reports of all operation and load tests shall be kept on file. Operational tests. All new below-the-hook lifting devices shall be operationally tested by or under the direction of a qualified person prior to initial use to verify the following as applicable: that the moving parts work properly, the latches work, stops are in place, limit switches are in place and work, control devices work, vacuum devices, you check alarms, and you check electrical systems. This is all as applicable. Now, load testing of below-the-hook lifting devices is dependent upon the type of lifter. Not all of them are required by B30.1. Structural and mechanical lifters. A load test of new, altered, or repaired structural or mechanical lifting devices is recommended by ASME B30.20, but not required. It's a should rather than a shall. If a load test is performed on this classification of lifter, then there are specific requirements, and the test shall consist of a test load that is 125% of the lifter's rated load, and written records are required for this test if it is performed. For vacuum lifters, a load test of new, altered, or repaired vacuum lifting devices is required by ASME B30.20. The load test shall consist of a test load that is 125% of the lifter's rated load, Written records are required when this test is performed. Close proximity operated lifting magnets. These would be the devices where the operator is in touch with the magnet. A load test of new, altered, or repaired close proximity lifting magnets is required by ASME 30.20. The load test shall consist of a load that is 200% of the lifter's rated breakaway force. Written records are required. Remotely operated lifting magnets. Load testing remotely operating lifting magnets is neither required or recommended by ASME 30.20. Remotely operating lifting magnets are the kind of things in a scrapyard where you set it down on the pile of scrap, you pick it up, what sticks to the magnet, and what falls off. You don't want to be around these things. Therefore, they're called remotely operated lifting magnets. Now, there's scrap and material handling grapples, and you don't have to test those. They do the same thing in the scrapyard as a remotely operated lifting magnet, but they come in with arms and teeth that go around the load, pick up as much as you can. Whatever doesn't get picked up falls off. Let's talk about the design of below-the-hook lifting devices. The design criteria for below-the-hook lifting devices is covered by ASME BTH-1. BTH, of course, stands for below the hook. The standard provides minimum structural and mechanical design and electrical component selection criteria for lifters. Let's hit the highlights. A design category, which is the static strength criteria, and a service class, which is the fatigue life criteria, shall be designated for each lifter. There's design category A. The design category A is designated when the magnitude and variation of loads applied to the lifter are well known. This is for the most part for specialized lifters designed to be used with a specific load under well-controlled conditions. Safety factor for design category A is 2:1 based upon yield strength of the material. Safety factor is also called design factor. Design category B is based upon the presumption that the loads applied to the lifter may have a greater uncertainty and that the lifting operations are performed in a more rapid and production-oriented manner and is in less well-controlled conditions. The lifters are what we all use for the most part every day. These are the spreader bars, that type of stuff. The design factor is 3:1 based upon the yield strength of the lifting material. If I can interject a little bit here, we just did an analysis of a bunch of pad eyes for a company. And the design factor in a connection like that is actually higher. The design factor is either 2:1 based on whether it's category A, or if it's category B, 3:1. There's a modifier to that. It's 1.2. So for a pad on a category B lifting device, it would actually be 3.6:1. And for category A, 2.4:1. Now, service class. Design for fatigue involves an economic decision between the desired life of the lifter and the cost. The intent is to provide the owner or the user with the opportunity for more economical designs where the duty is less severe or more specific and controlled. There's 5 service classes. I believe right now in the current ETH-1 there are only 4, but it's being expanded to 5. Service class 0 being used for occasionally used lifters that are specific to a load. And service class 4 is used for heavy-duty devices that are designed to last 30 years. Design category 5, or service class 5, is specifically for the nuclear industry. And they require a much higher design factor. Lift planning for the below-the-hook lifting devices. The key to safely using below-the-hook lifting devices is to have a plan that is well-made, communicated to all, and understood by all, and with specific personnel assigned specific duties and responsibilities. Everyone has to know what the plan is. Everyone has to agree with it. Everybody has to know what they're doing. Everybody has to know what their job is. There's a great document called ASME P30, Load Planning for Load Activities. It's a wonderful document. It provides planning considerations and practices to enhance load handling safety. I highly recommend it for everyone involved in cranes and rigging. And also Keith Anderson's excellent book, Rigging Engineering Basics. I highly recommend that too. It's a guide for lift directors, lift planners, rigging foremen, advanced riggers, crane operators, and engineers. Now, the governing documents for below-the-hook lifting devices are ASME B30.20, ASME BTH-1, and OSHA 1926-251. Any questions?
Awesome. Thank you, Paul, so much. We did get a couple of questions that came in. Let me pull one up really quick. So Dwayne asks, if gears or pulleys are changed out, does this require a load test? I don't know if you touched on that specifically when you were talking about that section, but once again, it's if gears or pulleys are changed out, does this require a load test?
No. How's that for an answer? That would be a mechanical lifting device, and a load test is not required. An operational test would be required. However, it's highly recommended that a load test be performed.
Perfect. Okay. Great. I got one more here, and then if you guys had any, I know we went over a lot, especially on the examples, but if there are any questions or if you wrote anything down, please submit them here. I can get it to Paul while we still have a little bit of time. But as of now, so we actually have Monty who's joining us from the Republic of Georgia, where it is 9 p.m. I think. I guessed it was 3 in the morning, so not even close. I guess I didn't have to share that part, but he asks, what are the periodic requirements for European standards as far as annual or semi-annual inspections of below-the-hook lifting devices?
Monty, first, welcome. The Republic of Georgia is a fabulous place. My oldest son has lived there off and on for probably a period of 4 years and loves it. He was a Fulbright scholar out of college and spent quite a bit of time there. My whole family has visited, and it's a wonderful place. I have not been able to go, unfortunately. To answer your question, I don't know. I'll gladly research that for you. It'll take a few days, but I'll get back through Jonah and certainly get back with you. Thank you for the question.
Yeah, sorry for a bit of a curveball there. I know you didn't touch on it in the presentation, Paul, and I'm far from the technical authority on anything, but I believe ASME would be referenced. Those are used around the world. The standards are at least referred to around the world. So yeah, we can do.
Yeah, there are additional requirements too that cover European Union. There's ISO standards. There's a lot of different standards. I think it's an interesting question that I'd be glad to look into. I'll learn a lot while I do it.
Excellent. Yeah, thanks again, Monty. I have one more that just came in, Paul. So Mark asks, OSHA requires lifting devices to be load tested to 125%. How could B30 ever be used in the U.S. without load testing?
Well, that's an interesting question. There's a controversy over that. OSHA required, via an interpretation to 1926-251, that all lifting attachments need to be load tested. However, ASME BTH-1 and B30 do not require mechanical lifting devices to be load tested. At Electric Boat, there is great controversy about this. Siemens makes a lifting device for their breakers, for their electrical breakers. We tried to get it tested, and as I talked to other people on the ASME B30.20 committee, they ran into the same thing at power plants, and Siemens refused to test them. So It's a really good question. It's an area of controversy. How's that for an answer/non-answer?
No, it's very interesting, and thank you again, Mark, for the question.
Yeah, it's a terrific question. There are similar inconsistencies, if you will, between ASME and OSHA, such as a documented wire rope inspection for a mobile or I say for any kind of crane used in construction. ASME V30.5 does not require a documented monthly inspection. However, OSHA does.
Mm-hmm. No, yeah, definitely. And throughout the industry, we kind of see this, and not to be a complete product shiller, but we have in our bookstore, in the ITI bookstore, we have reference cards, and one specifically is a rigging gear inspection reference card. And what it does, it lists different standards. So ASME standards, what is required, OSHA requirements. We actually have a Canadian version that lists the Canadian standards. So yeah, if something like that applies to you and your position, please check out those reference cards. They're laminated. There are 8 panels on them. I believe the price on one is $5 to $10. I should probably know that. But yeah, check out the ITI bookstore with those, and that not only rigging gear inspection, but we have them for various rigging applications. So
it points out another thing too, Jonah, that you really just can't go by one standard.
Yeah, absolutely.
There are OSHA requirements and there are ASME requirements. They complement each other. OSHA happens to be the law, so you have to follow that. It's possibly a higher standard, but ASME V30.20 and all the rest of the ASME V30 standards go into much more detail than OSHA does.
Yeah.
So if you're a person involved in this industry, it's an excellent question that the guy asked, but you have to be familiar with all the regulations and requirements that cover your particular applications of lifting and crane use.
Yeah, absolutely. Well, that's good stuff. More of a conversation, I suppose, than a Q&A session, but yeah, very, very good questions. Do you have time for one more, Paul?
Sure.
Okay. Thomas asks if you have any experience with hydraulic jacks used as below-the-hook lifting devices.
Can he give an example of the application? I'm not sure that a jack would be a below-the-hook lifting device. B30.1 covers hydraulic jacks. It also covers strand jacks as well as telescopic hydraulic lifting systems.
Okay.
I'm not aware, and again, this is great to get a question like this. If he could email me or you, I'd love to look into this one further too.
Okay, he did clarify a little bit, so that just came through, meaning used as sling adjusters, used to manipulate the load.
Oh, okay. Yeah, I wouldn't, it's probably not a hydraulic jack. It would be a hydraulic ram, a cylinder. That, yes, I've seen those used. There was a nuclear application at the electric boat site up in New York State where instead of a turnbuckle, they used hydraulic things. I think Enerpac makes such devices, and I believe if he checked with Barnhart or Bay Crane, they have similar devices. So good question, but it wouldn't be a jack per se, it would be a hydraulic cylinder. Or ram, double acting, so it could extend or retract to level, usually just like he said, to level a load.
Gotcha. Okay, and thank you for clarifying your question as well, Thomas. Well, with that, we can probably wrap things up. I just want to remind everybody that we recorded today's session. I can get that out. We got to get it processed and everything, and I'll make the link available to everybody who's online, everybody who registered. So thank you again. Thank you to Paul for your time, and yeah, his contact information, Riverside Engineering, and his email and everything is on the screen there. So I hope if you guys do have questions, feel free to reach out to him directly. You can also go through me if you'd like to, Jonah, Jonah, @iti.com. And while I have you guys on the line really quick, I'm going to grab the screen back briefly.
Thank you, Jonah. Thank you, everyone.
Yeah, absolutely. Thank you, Paul. So I just want to show this very briefly. I don't know if you guys have heard of the virtual reality crane simulator we're going to be bringing to the market in the spring of 2017. We're going to launch it at ConExpo in Las Vegas, at the show there. But please check out, I don't know if it probably won't apply to everybody on the line, and that's okay, but iti.com/VR, you can see kind of a shot of it there. I could talk about it all day long, but until you actually get on one and try it, that's what's really going to show the difference between current simulator offerings. But this thing, all of our instructors who have 30+ years industry experience, they hopped on it, very skeptical, and yeah, they were amazed with it. So it's a headset, and then you have the headset on. There's controls, which we don't even have the controls yet because it's still in development. But yeah, the realism of the product and what you're doing and how it interacts with your movements, it's pretty incredible. So we're proud of this. Definitely check it out. If you have more questions about this, the website can address a lot, but you can email me anytime too. So just wanted to get it out there, let everybody be aware of it, and yeah, check it out if you are interested. So with that, again, thank you to Paul. Thank you everybody for taking time out of your day and joining us. Another great session of the webinar series. We'll be back in October. I believe we're going to have Jim Jatho. He is a lift planner for Buckner Heavy Lift Cranes. He's going to be our guest presenter, and I'll have more details on that as soon as possible. So thanks again. Look forward to joining everybody next time. Have a great day.